Okay, as example, for 2, z will be 0, y will be 1, and x will be 0, and w will be 0. You got it? Okay. Now, if we talk about, as example, any number, it's constructed here. Okay. For A, B, C, D, E, F. By the way, I put points to mention that there are others, F and then G. Okay. In this way, you can fill the table. So these are the inputs which we are going to construct in logic gates, and these are the output of the 7-segment display. Based on the inputs, you know the output. Okay. As example, if you remember, if you want to construct 1, then B and C constructed. You see here are the 7 segments. Okay. These are 1, 2, 3, 4, 5, 6, 7. If you want 1, this should be not there, this should be not there, this should be not there, and this one, and this one. Whose should be 1? Only B and C. You see, just a minute, this is 1, B and C, and all others should be 0. Agree? This way we can understand how it works. Now, binary coded them again to 7-segment display. We will minimize the sum of product representation for each output. It means for A, for B, for C, for D, for E, and for F, and for G. For each one, we follow the same procedure. Now I will start working on A as example, and B, I give it to you as exercise. You work at home to find B. You see here, only this is for A. We mentioned that we represented by wx, y, z. So I will put here, as we learned before in Karnaugh map, wx, and here yz, and I start fill the table. Okay, it's from the truth table, previous slide. I start fill it. I fill it. You will see some cases is not there. As example, there is no cases for wx when it come 1, 1. You got it? So this need to be considered. We are going to use technique called don't care condition. Don't care condition, it means we will put X whenever the option, whenever the situation or the case is not an option. We will put X. You see here, X is, it means there is no output here, neither 0 nor 1. You see, it's not an option. And zeros and ones everywhere according to the truth table, which will lead to reduce the expression. You remember we kind discussed before, and we mentioned we use it to simplify and reduce the expression. Now next, I will circulate the biggest groups of ones and don't care. I mean ones and X. You see here in the shaded area, ones and X's. This is happen whenever we have one. Just a minute. This is 1 for Y, and this is 1 for Y. Just a minute. What about z10? We cannot use it. So only ones. 1, 1. This means, okay. The first expression is, I will call it FA1 when we have Y. Okay, this is the first part. Ones and don't care group. Just a minute. This is also ones and don't care group. I will call it FA2, the output, as you can see here. Just a minute. It seems to be when W is 1, here, see here and here in both, then we have this group. Great. Then I will say it is W. Still work time. Okay. Now also here you can see here, this is another group here of ones and don't care. Okay. It happened when we have Z1 here, you see here, and Z1. So I added Z, multiply by when we have here X, sorry, yeah, X1 here and here. So XZ will give me this group. What is left? What is left is this one. You see here, and this one, and this one, because it's coming with X. Okay, so I put it here in this way. Just a minute. The first one here, the first one, these fours, because they are corners, let's see what is the common between them. Okay, the corners, it means this one related to this one and this one related, or you can say this one related to this one and this one related to this one, as we discussed before in Carnot map. The adjacent, we call them the adjacent. Okay, what is the link between them? Just a minute. For y and z, 0, for y 0 1 we cannot play with it because it's different, but 0 0 we can say it is z dash. Yeah, I put z dash. Great. And for here 0 1 for w we cannot play with it, but 0 0 oh, we can't say it is x dash, so I multiply x dash. Now here for products, I can't put them. You see here I shaded them because it is there, and I represent them by this sum of products. You see how I moved from the function itself, which is 7 segment display, to display the 10 digits from 0 to 9 across 7 segment. I need the logic who can run this. Okay, so I start from the function to create truth table, and then I move to to put this truth table in a Carnot map to simplify. Okay, and then I have the final expression. Now this is example. This is example about the 7 segment display decoding. Okay, the opposite. Okay, here you can see here we have a clock. Usually in the computer we have a clock which sends the signals. Okay, to operate this count, and this count we have 1 2, as you can see here, 1 2 3 4 5 6 7 8. Okay. And here, let me say, this is the digit. It's coming, the opposite. This is the digits coming to send the pulses, okay, to this logic gate, which is constructed already. Then it gives the output to the, this is segment 8, by the way, and decoding 7 segment display. Now, this is just to show you how it look like inside as a computer, as example, or a receiver for your TV at home, or other appliances. Now, I advise you, okay, to repeat the same discussion for B. I mean, till now, the example to cover A, this is A, as you can see here. Repeat the same example for B. I started here putting the, for you, the Carnot map for B. You put the don't care and start circulating the largest group of ones and X, which is don't cares, as we explained in the previous example. And you need to cover, don't forget to cover all ones, and then you come with the expression which represent the segment B. This is example. Take it with you and try to work on it at home. As I mentioned, part of my part is to explain to you, to discuss with you, to try to facilitate things for you, but you need to practice at home. My advice, try to practice at home. Now the summary of this topic is need to formulate circuit for problem description. We need to determine the number of inputs and output, determine the truth table, formulate the truth table, use Carnot map to minimize the expression, and then come up with the minimal sum of a product. It could be multi output per design. Okay, this need more effort. Now next approach, by the way, here the output is directly displayed on the 7 segment display, but next we don't have memory. Next topics we are going to cover the memory. Good luck and see you next topic.